Hello.
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 Hi, y'all. Just letting everybody in. It's a lot.
Hey.
Hi, everybody. Welcome back. We have about 13 of us in, so waiting for a few more here. We're coming all in. All right, y'all. Welcome. It's 101, so let's go ahead and get started. Welcome back, y'all. So, our quick check-in question again is going to be in the chat, just so I could double check who's here and who's not. Is how much energy do you have right now? Scale of 1 to 10. 1 being your energy is really low, 10 being your energy is really high. All right, we have we got a good amount there in the chat. Let's see where everyone's energy is at. So we have some 5s, so like medium energy, some low energy, 3s, 2s, 1s. All right, we have a 10 there from Ryan. That's awesome. 7's pretty good. We have about a 4, 1s, 5. So, 0, very low energy. And then we have mediums. And then, I don't know, honestly. As for me, I am okay, Ryan. Awesome. I hope you do well in that interview. For me, I'm like at a 6, because it's weird, like the cold. Our heater broke like last year, so we can't really use it. So the cold kind of makes me a little bit lazier. That's just me though. But for me, I'm like at a 6 as far as energy. Yeah, cold also makes me sleepy. Like I sleep earlier. I sleep earlier and I want to sleep in. Yeah. So that's where we're at. All right. So a lot of us with low energy, very few of us with a bit higher. Let me go ahead and read who I have absent here, and y'all can correct me, and or you could text them so that you can encourage them to come into class. We have, hold on a sec. You just got someone. All right. So this is who we don't have. I don't have Jalen. I don't have Jasmine Beltran. I don't have Gabriel. Denise, Miles Ford, Jirel, Carlos, Leon, and Sincere. So that's who I'm missing. Again, let me restate that because we just had a few just come on in. If you just came in, yeah, if you could please answer that quick check-in question, so I could get you as present. All right, so again, we're missing Jalen, Jasmine, Gabriel, Denise, Miles, Jirel, Carlos, Leon, and Sincere. So that's who we're missing. If you're friends with them, if you could let them know, send them a text. They definitely don't want to miss this first class because we have um, some participation going on. And it's going to be entered in because I definitely want to make sure that all the participation you're doing in class gets, recorded. You get your credit for it. All right, let's go. All right, so here's our agenda, everybody. We're going to be starting fresh, new module, y'all. We just checked attendance. We're going to be actually taking some notes today, something called Sigma notation. Maybe you've seen it. Maybe you remember some of it from your Algebra 2 teacher. Then we're going to have an exit question in the last few minutes. That's going to be an exit ticket that you want to complete. It will be for credit. Credit as in participation, not whether you're right or wrong. So as long as you do it and you try your best, you get your full credit. Yay, we got Sincere. Woohoo. All right. As a reminder, I'm also going to be sending a group preference form through Remind. So after this class is over, I'm gonna send it. If you could fill it out because for our next class, we're gonna be having a group activity, and I wanna make sure that you all have some input on who you want in your groups. Because if y'all remember from last module, I would put you into random groups, and like I acknowledge that that's not always 100% effective, especially if you work with someone else better. So I'll be sending that out through Remind. And asynchronous number 8 is posted already and it's due on Tuesday. Asynchronous number 8 is going to be based on the stuff we talk about today, Sigma notation. I definitely encourage to do it because it's like Khan Academy. And so you could click I'm stuck and it helps you, gives you steps, things like that. So it's really cool. So that's just an update on the attendance and what's happening. We just had 2 people come in. If you could please private message me so I could mark you as here. Now we got Sincere, and then we got Jasmine Beltran. All right, awesome. Happy. Thank you so much for being here. All right, so just as a last thing, we're missing Jalen Baker, Denise, Miles Ford, Jirel, Carlos, and that's it. But if you could send them a text, that would be great. Let's get on with it though. So you want to have paper and pencil ready since we're going to be starting some fresh notes today. And get yourselves ready. Just give me a few seconds here. All right, let's go. Sorry, somebody's in the waiting room. So here's the title of our notes, Summing It Up with Sigma. And the learning target is I can calculate sums by expanding Sigma notation as well as writing series in Sigma notation. So that's going to be our learning goals for today. Yay, thanks, Diane. You're ready. So go ahead and copy down this learning target. As you're copying this down, I don't know if you all have dealt with Sigma notation, but if you haven't, this is, I'm drawing it right now. This is what the Sigma notation looks like. It looks like a funny giant E. I did it right now. To be honest, I feel like I did this wrong. It should look, I don't know. Yeah. When I would write this on the board, I would be very messy and I'd write my E's something like this if I'm on the board, very messily, but it looks something like the first one I did. This right here is a sigma and it's used to represent sums, and we're going to learn how to use that today. So again, you may or may have not seen this before, but I'm going to teach it as if you haven't. So it's going to be like a fresh start there. All right, let's have a few more seconds on writing down this learning target. All right, y'all. I hope you got your learning target down. I was just taking a look at everyone's profile pics. Very cute and interesting. All right, so let's go. So we're gonna jump into the first example, y'all. So let's go ahead and write this down. I highlighted the words that we're gonna talk about, like defining what they mean. So it says carefully evaluate the sum of the sequence represented by, and it says t t of the nth equals 0.01 n plus 1.7, where n equals 2, 3, 4. So don't worry, we're going to do this example together. We're going to break down what in the world is this problem trying to ask us to do. Don't worry, it's gonna be straightforward, but let's just first copy it down and then we'll start with it. So we're gonna be doing a sum, and we're gonna talk about what sum means in sequence. So first copy this down in your notes for me, and then I'll start talking about the next steps. All right, yay, we got Jalen here. Happy. This is awesome. We're getting more and more. Thank you for those who are texting your friends to come on in. Yay, we got Miles Ford. Welcome, welcome, those who just came in. All right, so hopefully you got this copied down. Let's first break down. Yeah, no problem. I won't switch this slide for those on here. Don't worry, we're gonna just break down the first what we're being asked to do. So let's define some of this stuff. So sum and sequence. First off, what does a sum mean? That's okay, but basically means adding two or more numbers in a regular way that you think of sums, like even in elementary school. Sum means adding two or more numbers. So we know, given that they're asking us to find a sum, that we need to add stuff together, okay? Next word that might be new is sequence. So sequence is a list of numbers or objects in a special order. Obviously, in math class, we're not going to be talking about a list of objects. So you could just say this is a list of numbers in a special order. So basically what we're doing is we're going to have a list of numbers in a special order. We're going to take them and add them all up. So that's what this problem is asking us to do. So again, we want to make sense of what we're being asked to do first off, and then we can start solving. And then again, we're also given this here function. We're given t of the n equals this. And we're being asked to kind of substitute for n. They're saying n is 2, n is 3, and then n is 4. All right, so we have a function and we have some inputs. Let's go ahead and just try to plug in those things, and then we can maybe get that sequence, that special list of numbers. So let's go. Step 1, let's go ahead and plug in 2 into our function. Let me change my thing. So the first one they're saying is n equals 2. So I'm taking 2 and I'm going to plug it into my function for n right here. So that's where I got this first part. T of 2 is equal to 0.01 times 2 plus 1.7. If you use a calculator, you're going to get your answer is 1.72. So that's the first list. That's the first number in our list when we're making our sequence. Now we're done with 2, so I'm going to erase this. The next number that we want to plug in, so we're done with 2. I'll just cross off my 2. I'm done with it. The next number we're going to look at is n equals 3. So you're going to take 3. You're going to, again, plug it in for n to get your next number in your sequence. So let's do that right here. So again, you could use a calculator or you could use your phone calculator. You can even use Google Calculator. But if you do this math work, you do 0.01 times 3, then you add 1.7, you get 1.73. So that's the next number in our sequence. This is me trying to use that definition there of what a sequence means. All right, and it looks like we have one more number to do. We're done with 3. So let me just erase that. 3 is done, so I'm gonna cross that off. Last number that's going to make our sequence is 4. So I'm gonna take 4, I'm gonna plug it in right here for n. Once I do that, we're gonna have our last number because that's the last thing they want us to plug in. Again, you do the same math here, you use your function and you get your last number in the sequence, 1.74. Yes, so someone asked a clarifying question in the private chat. So we're just putting different numbers in the same equation each time. Yes. So for this specific problem, because you were given a function and a set of inputs, to create your sequence, you're just going to take those inputs, you're going to plug them in one by one to get your sequence that you desire. And because they said we're going to evaluate the sum of a sequence. So yes, that's correct. All right. So this right here, this list that we just developed, what we're going to do is first off connect what we just learned as far as terms. Is this right here is our sequence. That's the list of numbers in a special order: 1.72, 1.73, and 1.74. Now let's finish up the problem. The problem says we need to evaluate the sum of our sequence. So that means we're going to take our sequence and we're going to add them all up together. That's going to give us the sum. So if I add these numbers up together, I get 5.19. That's basically my answer here for this example. Boom. So I'm gonna just pause here for any clarifications, any questions. I'm also gonna pause so that you can get this down. Let's give a few seconds and stuff. As y'all are getting that down, I'm just gonna check who we don't have again, just to make sure. So again, I'm now missing just Denise, Jirel, Carlos, and that's it. So we're just missing 3 people. If you could get into contact with them, that would be awesome. So question asked is, wait, would it be t to the n equals 5.19 or just 5.119? It would just be 5.1, sorry, 5.19. It would just be 5.19, that's correct. So not t of n, yeah. All right, thank you for the question there. That's coming in privately. All right, y'all, let me know if anyone else has any questions on this, but that's a sample of how to do a problem that's asking you to do a sum of a sequence. And if you're given a function and some inputs, that's how you would do this type of problem. But we're not really necessarily just doing this, of course. Our goal is to learn that sigma notation, right? And sigma notation has a lot to do with sums. I believe I have more vocabulary first, though. Definitions for y'all to know. The first one right here is a sequence. So a deeper meaning of sequence, basically it's a list of numbers in special order. And sometimes you call like the first one is first term, second number is your second, and so on. Sometimes you might have a sequence where it has dot, dot, dot. The 3 dots means it goes on forever. And term, element, or member mean the same thing, like first term, second term. I think I'll just use term. I don't really use element or member. But that's just in general what a sequence is. Sometimes you might notice that your sequence has a pattern. For this instance, I noticed that there's a pattern that each time it's, I think it's adding by 2. So 3 plus 2 is 5, 5 plus 2 is 7, and so on. So sometimes there's a pattern, and we're actually going to be looking at sequences that have a pattern to create our sigma notation, the thing that we're going to learn today. So yeah, sometimes there's a pattern. Doesn't always have to be one though. So that's sequences. Next definition, series. So that you might see this word being used. Series is basically when you sum up all the terms in a sequence. That's basically us adding it all up. That's series. I don't really use this term, but if you see it, you want to know what it means. Like sometimes if we're looking at a sum with plus signs in between, I might say, look at this series. The last one is sigma notation. So this symbol right here, it's actually a Greek letter. It looks like a big E, and it's used as a compact way to represent sums. And that's going to be our learning goal for today. That sigma notation right there. And it has a lot to do with series, and it has a lot to do with sequence, and then it also has a lot to do with with summing stuff up or adding them all up. Let me leave a few seconds on this slide so y'all can get these definitions down. And then any questions are totally welcome as well. Feel free to unmute or private chat me, it's cool. And yes, you want to write this down. These are your notes, these are definitions to know. Yes, you want to write this down. All right, I'm hoping y'all got these definitions down and in your notes. Yes, you want to take notes right now. Note collection could happen at the end of class today, or it could be at the end of class. The next time we meet is going to be Thursday. Remember, Wednesday, y'all have Veterans Day off. So we're not meeting on Wednesday. We're going to meet on Thursday. So that's as a heads up in case you didn't know from advisory. And yes, I'm going to be posting the slides on Google Classroom as well. So you could always go back to it if you still need to finish up the notes. All right. All right, guys. So we're going to be moving into participation, and this part will be going into Google Classroom, into PowerSchool. So I will be grading participation, and it's going to look different now. So we're not going to be putting it in the chat like we used to. I kind of noticed that only there was 5 active participants in the chat. So I want to make sure that we're all involved and I give credit to everybody. So we're going to be doing a notice and wonder on this right here. So this is Sigma notation. We're going to first do a notice and wonder on it before we learn how to actually do it. And basically you're just going to put down a notice or a wonder on a Google Doc. Let me show you how this Google Doc works. And let me put it in the chat. So the Google Doc is in the chat. And I'm going to click on it as well so y'all can join me because this is part of our participation. All you got to do is take a look at here, this example of a sigma expression. And there's they have little arrows pointing to what something means. What you're going to do is you're going to put your name or initials in the columns there. Now, if you're uncomfortable with your name being shown, that's why I want to give you you could put your initials. Like if you're shy, you don't want your thoughts being, read out loud, you could put your initials. That's totally fine because I could still track down who you are and give you credit. So yes, this is for everybody. So everybody wants to be on this document. You're gonna start editing it the same way that we're seeing everybody doing that now. Again, this is super accessible because all you're doing is putting a notice or wonder. Feel free to add more numbers down here like 18, 19. I stopped at 17, but we obviously have more than 17, so 8. So we have 13 people on this document, but we have 23 people, so we still need 10 people on here. This is for participation, so you want to get in on this document. All right, we got 14 of us in here. We need 9 more people on. All right, great. We got 15 in. And great, 16. So we now need 7 more people. You do not want to lose your credit. Make sure you come on into this document. All you got to do is put a notice or wonder here. All right, so we just need 6 more people to come on in to this document. And let me again put the link to the document on the chat for those who are struggling to get to this document. You just click on the link and you should be there. Good, we have 21, yes. All right, go ahead and take about a minute to finish up. What are some notice and wonderings about this expression that you see up here? And after we do this notice and wonder, we're going to take a look at an actual example. Again, put your initials or your name for credit. We're just missing 2 people. All right, it looks like we're just missing 1 person there to get on the document. Awesome, y'all. Let me start my timer now. I'll give you all a minute to just put down some notice and wonders. If you're done, you can just sit back and take a look at what everyone else is noticing. All right, a few more seconds and we'll all take a look at what y'all are noticing and wondering. All right. Great. So let me point out a few of the notice and wonderings. Please make sure you finish up. Putting in a notice or wonder. You cannot be wrong with this, right? There's no way you could be wrong with a notice or wonder. So yeah, I noticed the same thing. The note right here, it says, I noticed that nothing is happening in the back of the symbol. That's right. You see something in the bottom, the top, and in the front of the symbol. Nothing's happening in the back. I agree with that observation. All right, let's noticing that the sigma expression represents 4 values in total. I wonder why the first value of n is important in ever changing the formula. Yeah, that's a good wondering there. I notice that there are 4 parts to sigma notation. Yep, the E has numbers around it. Yeah, a lot of you are noticing about the 4 parts. Okay, so I noticed that all important details of the sequence are in the sigma expression. Yes, I like that one because that's going to lead us into it. I noticed that the n value shows up 2 times, one in the middle, one in the sigma, and then one at the bottom. That's a good noticing. I notice it has 2 n in the equation. Oh, 2 n's in the equation, yes. And the value of n is below the equation. Oh, wow, I didn't notice that. I noticed that the numbers on the top and the bottom of the symbol look similar to division. Oh, okay. I noticed that certain numbers are placed in a specific order to maybe solve the equation. All right, so these are awesome noticings. I'm wondering, I personally notice some of you are not done typing, so make sure that you put your name and you put what you notice and wonder for your full credit on this. Again, I want to make sure I'm grading the participation that y'all are doing in class. Awesome, y'all. So I'm going to go ahead and move away from this document, but that does not mean to not complete it, right? So if you're not done, please get your thoughts in. But we're going to go ahead and move on with our notes so that we can actually know how to do all this. So thanks. A lot of you were talking about like there's this bottom number, there's numbers around it. Perhaps it has to do something with our sequence. Like maybe the start value has some impact. Some of you notice about the formula in front of the E. All right, let's go ahead and actually learn how to do this with an example. Here's our example, everybody. So we're going to do this one together. It says example 2. Write the following sum in expanded form and then calculate the value of the sum. So write the sum in expanded form. So sum is important. So we know we're going to be adding stuff up. And we know that sigma is going to be representing a sum. So I'm just going to put the E right by here. So this is a sum. And we have to do something with expanded form. And then we're going to have to actually calculate the sum. So we have to do some calculations. All right, so that's just important things to know. It sounds like, can you tell us if we're good? Actually, I guess you'll see now if you're what you noticed or wondered. All right, so here's how it goes, everybody. So how do we do this? So notice right here, it has a J instead of an N. Y'all notice that there was N's in that last one. But this right here, this J or N or whatever you want it to be is just a variable. So we could change it to whatever we want. We could use I, we could use X, we could use Y. In this case, they're using J. It's a variable, and usually it shows up twice in your sigma notation. Always at the bottom, always at the index value, and then always in your function. In this case, it's 2 to the J power. All right, so this right here is going to tell us what to start plugging in. Let me type that there. So it's saying that we're going to start by plugging in J equals 3. Oh, darn. Well, there we go. And this number at the top, what does this tell us? So this right here is going to tell us where we stop plugging in for J. Let me also type that out. Into J. Yeah, it's the best way I could kind of phrase it. Let's do this. So it says we need to start with plugging in J equals 3 into our function. So let's do that. So notice I started here with J equals 3, and then I continued counting up the integers. So it went to 4, went to 5, oops, and then it stopped at 6 because that's where we stop. This number up here tells us when to stop plugging into our function. And this number here told us where to start. And then you need to include the integer numbers in between the start and the end. And that's going to be your series, and that's going to give you your sequence, and that's going to give you your answer ultimately at the end. So that's how this is helping us set up a sum. See if there's anything in the chat. No, you're good. So Danny, you put 2 to the third is 8, or am I? No, you're right. So the first one is 2 to the third. But because this is a sum, right, we're going to be adding multiple terms. You're going to keep going. So you plug in first 3, then 4, then 5, and then you're going to stop at 6 because that's where it tells us when to stop. Next, we are going to evaluate each of these. So 2 to the third power, that's not 2 times 3. 2 to the third means 2 times 2 times 2. 2 times itself 3 times. So this is what you get when you do the math. So 2 to the third power is 8. 2 to the fourth power is 16. That's 2 times itself 4 times, should be 16. 2 times itself 5 times is 32. 2 times itself 6 times is 64. So that's our next part of the process. I'll let you all copy this down. And then it says that we need to calculate the value of the sum. So now we just gotta add these all up together. We could use a calculator. You could use your head if you're quick with calculations. Let's see what you all get. Maybe I'll let someone know in the someone answer in the chat. What do we get when we add all this up? 120. Someone got 120. Okay, two of you got it. Let's see if I'm right. Whoa, okay, good. Because sometimes I have errors. Yeah, we do get 120. Y'all are right. All right, a lot of you got 120. That's our answer, basically. So we went from trying to interpret what the sigma expression is telling us to actually come up with a sequence. So this right here is a sequence. It's because we have plus signs in between. And then we took the sum of that sequence. So we added all these numbers up, we took our sum, and that's our answer. So our answer to this sigma expression is 120. So basically, you could see here how sigma is used to represent and condense a sum. It like gives you a smaller way to look at sums. And we're going to be using this throughout the unit. Let me know if anyone has any questions on this. But let me go ahead and just stick here for 30 more seconds. And then we're going to go backwards in the next example, you'll see. All right. So let's move on to the next one. So here's one version of how to do sigma. Is basically being able to interpret a sigma expression to evaluate a sum, but you might be asked to work backwards, where you're given a sum, like a number, a set of numbers, and you're asked to create a sigma expression. A lot of more people struggle with that version of it. So let's take a look at that type. That is example 3 for you all. So here is a series. Here's a list of numbers with plus sign in between them. And we're being asked to create the sigma expression to represent this sum. So that's the part that sometimes, a lot of us struggle with. So going backwards now. And let's go ahead and copy down these numbers, and then let's see if any one of you notices like what particular pattern is going on or anything in this list of numbers, because that's what we're going to be using. We're going to be focusing on what pattern is happening here.
They're multiples of 3.
They're multiples of 3. Let's take a look here. Yeah, so let's see, 3 times 3, that is 9. 9 times 3 is 27. 27 times 3. Y'all could confirm it, but I do believe that gives us 81. And 81 times 3 should give us 243. Yes, thank you, CJ. This is indeed the pattern that's happening here. We're multiplying by 3. And that's going to highlight the steps to doing this type of problem. So here's the steps for everybody. Number 1, you're going to be creating a rule or function based on the pattern. So the pattern we just saw, multiplied by 3, is happening. That's the pattern. So we're almost done with step 1. Then step 2 is you're going to test out the rule you come up with for accuracy. And then step 3, you're going to decide on the correct index starting point for your sum. So these are the steps that we're going to go through. Lastly, number 4 is decide where the upper limit ends. I'm going to again review these, the new terms that you're seeing here. Okay, there's some stuff in our chat. Yes, you want to write down the steps in your notes. That's correct. Because we're going to go through these steps to create the sigma expression. All right, so we already noticed that the pattern is this is multiplying by 3. So step 1 says we need to create a rule or a function to represent that pattern. So there's 2 things I'm thinking about when I think about multiply by 3. I think we could say, and I'm going to use n, y'all. I'm very comfortable with n as a variable, so I'm just going to stick to n. Let me use black as my color. So here are the 2 options I'm thinking about. I'm thinking the equation could be something like 3n. Or the equation could be something like, well, I don't know. I feel like 3n might, unless someone else has other options. Multiply by 3. Oh yeah, here we go. It could also be something like 3 to the n power, because I know 3 to the n is like 3 being multiplied by itself. So these are the 2 that I'm like trying to test out. Like, it could either be this one or 3 to the nth power. Let's see what's in the chat. Okay, so Brenda is saying 3 to the n. Someone's saying the first one. CJ saying the second. All right, so because one of you said the first one, why don't we test it out? Step 2 is to test out your rule. So we're going to figure out which one it is. So I'm going to start plugging in. So let me say for this one, n, I'm going to plug in 1. So if I plug in 1 for n, I'm going to get 3 times 1. That does indeed get me 3. Yeah, I do get 3, so that's a check. All right, what if I plug in n equals 2, the next integer? That's how it works when you're doing these sums. If I plug in n equals 2, I'm going to get 3 times 2. That equals 6. But if we look back at our second term here, we don't have 6, we have 9. So we could see that this first one here will not work. This didn't work after we tested it out. So that leaves us with this one, the second one that y'all were saying. But of course, you want to test this out. Sorry, there's a fly around here. All right, let's try the second one, y'all. So I'm going to try to plug in 1 again. Oops, I want black. 3 to the first power is 3. And that checks off. Check. Now we're going to do n equals 2. 3 to the second power. So that's basically 3 times 3. That does get us 9. So far, so good. Now let's check the third one just for safety measure. 3 to the third. That's 3 times 3 times 3. That does get you 27 if you all check that. So far, I think the winner here is 3 to the n. So that's going to be our function. So we did step 1. We found a function that works, and we also tested out some numbers. It seems to work. Now we're going to go ahead and create our sigma expression. We got to decide on the correct index starting point and where the number ends. Let me check the chat right now. And then, see, you said, never mind, it's 1. And then someone said, could you send me the recording of this class after class, please? Yes, of course. I'll send this recording. I could also send it on Remind if everybody wants it. Okay. So let's do this, y'all. So I'm going to start by drawing my sigma expression like this, nice and giant. And right in front of the sigma goes on the function that we decided on. 3 to the n worked, so I'm going to put 3 to the n. Now, step 3 says decide on the correct index starting point. The index starting point is the part that goes at the bottom right here. N equals, and again, we're using n because that was the variable I was comfortable with, so I'm just continuing to use n. What was the first value for n that we plugged in? Awesome, and a lot of you want the recording, of course. Okay, I'll send it through Remind then so that everyone can access it. But my next question for you all, okay, so Risha put 1 question mark. Yeah, so if we look here, right, the first value we started to test out was when n was equal to 1. It also shows up right here. So yes, my correct index starting point, that's what this means right here, is n equals 1. That's correct. We started at n equals 1. Now, the last thing we need to completely finish up our sigma notation is to decide where the upper limit ends. That means, what is that number that goes up here? What is the last n value that we need to plug in to get 243? Because that's the last number in our sequence. What n value works? Let me know if anyone can figure that one out. So Danny put 5. We could test it out. So question mark, so 5 question mark. Well, let's test it. All right, so let's keep going. So 3 to the 4th. Yes, if you all check that, that does give you 81. You do 3 times itself 4 times. 3 to the 5th. Yeah, you could test it out. So 81 times 3 should give us 243. So the last number we end up plugging in is 5 to get the last term in the sequence. We plugged in 5 to get 243. So therefore, this top number, we call it the upper limit, is 5. So we have fully completed the sigma notation expression that represents this here sum. So again, these were the steps. Number one, we first found the pattern. Step two was step two is not really step two. We first found the pattern, then we made the function. The function we agreed upon was 3 to the n power. After that, we had to check the accuracy of it, check your work. That's step two. Step three is we needed to decide where do we start plugging in and where do we end plugging in. And then after that, you're basically done creating your sigma expression. And basically, let me circle the answer here. This is the answer. All right, let's see, we have two stuff in the chat. Couldn't you have just counted the numbers and see how many numbers there was so you know where to end? You could have for this example, yes, Zion. Sometimes though, sometimes your first number that you plug in could be 0. So sometimes the first number is not always 1. So the index is not always 1, depends. But for this example, yes, you could have just counted it and it ends at, oh, I'm sorry, that was a private thing. So you could have just counted it and ends at 5, but it's not always the case. Sorry about, yeah, that was a private chat. But there's our answer. Let me know if there's any other questions on this before we jump into our exit ticket. And that's going to be the end of our class after the exit ticket. It's going to be basically asking you some questions about sigma notation. Let me know if anyone has any additional questions. And for your grade today, you're going to see it say Google Docs / exit ticket. That's just going to be our participation for today. And again, in your exit ticket, please try your best. You don't want to put IDK. That's not going to get you credit. Just try your best to answer the question, even if you don't know. Just give it your best shot. All right. Let me go ahead and clear this screen, everybody. All right, so our exit ticket, it's a Google form. Let me just grab it for you all. And I'm going to put it into the chat. And yes, you want to complete this for your credit. It's the last thing today. Let me open it with you so y'all can see what it's about. So it looks something like this. You're going to put in your email address. Number one says, in your own words, describe how to evaluate a sigma notation expression. So this one is asking about example 2, the one where we evaluated. So this one's about example 2. Number 2 is going to ask you to evaluate the sum. I'm trying to make sure that, yeah. It's going to evaluate the sum in expanded form and then calculate the value. So here's a new problem for y'all to do. Then number 3 is any questions that you have for me today about our learning target, about sigma, and all of that. So that's our exit ticket. And basically, it says 59, so we have to, this class is about 22 right now that are in here. 22. Yeah. So 59 plus 22. So it should hit like 81 once we're all done with this. So I should see that number there. Okay, and then someone asked, well, what if I don't get it and I don't know how to explain it? You're just gonna try your best. You could say, I get this and this, but I don't get this, and that's totally fine. What does it mean by evaluate for number 2? All right, let's check it out. So number 2, you should be looking at example 2 that we did together. You should have this in your notes. Let me show you. Example 2 was this one here. This was the exact same thing that you're being asked to do for number 2 in the exit ticket. It says write the sum in expanded form and then calculate the value. So that's the one where you're given a sigma, you expand it like this, you add it all up to get your answer. So that's what they mean for number 2 in the exit ticket. I hope that was that clarified that. Oh, someone said I mean number 1, sorry. And number 1, so this is up to you how you all interpret this. You can't be wrong with this. So in your own words, describe how to evaluate. And yes, that one is actually also asking in your own words, describe how you are to evaluate based on example 2. So again, number 1 and number 2 are about example 2 for the exit ticket. So yeah, you're looking at example 2 for these two. Says for number 2, do we include the n when doing the equation or no? I'm not exactly certain what you mean by that. Because if you look at the example here, when I evaluated, my answer didn't have any J's in it. So your answer for number 2 shouldn't have any N's in it. I hope I understood that question though. So it should look like example 2 in our notes. Okay, cool. All right, let me know if there's any other questions about our exit ticket. We have 2 people from this class that have completed it. Awesome job. I just, I'm not gonna, I don't wanna expose anybody's answers. All right, great. Tori and Yaisa are done. Awesome job, y'all. And then we're just gonna wait until we hit, we need about 80 responses from this class because our previous classes have done this one already. Cool. Let me know if anyone has any more questions about the exit ticket for today. I'm happy to go over and explain it some more. All right, good. We have a total of 5 so far who have submitted the exit ticket. Awesome. Again, if you're part of that 5, let's see. So if you are Tori, Yaisa, AJ, oops, sorry, my thing got messed up. Oop. If you are Tori, Yaisa, AJ, Jasmine, Montez, Sam, or Celia, you all are free to go. I'll see you all soon. But the rest of us, let's continue to finish up our exit ticket. Give it your best shot. And Risha, you're free to go. Thank you so much. All right, we're getting more in. Those who already got them in, you're free to get going. I'll see you all soon.
All right. Have a nice day. See you guys later.
See ya. Bye, Zion. Oops. Bye. All right, y'all. I think we just need like 9 more. Feel free to take your time, or if you want to really, process this, no pressure. Bye, Danny. Thank you. See what? All right, Jalen, I'm gonna go ahead and end this meeting. Feel free to take your time on the exit ticket. Oh, did we already get it? Yay, I got it. All right, bye, Jalen.
Bye.